Hello, everyone. It is a pleasure to be here. I will present the ontology and data modeling for the Italian Arthroplasty Registry. My name is Riccardo Valentini, and I'm a PhD student at the Department of Computer Control and Management Engineering at Sapienza. And here's my email contact. I will briefly introduce the context of this work, and then I will talk about arthroplasty ontology and database to focus lately on the main impacts of this work and to conclude with the future scopes. Today, data have become more and more important. In fact, in 2017, the Economist stated that the data is the world's most valuable resource. And within the healthcare context, a proper data exploitation in the end of the stakeholders can really have impacts on the patient's lifestyle. In particular, my case study is the Italian Arthroplasty Registry, RIAP, which started its activities in 2006 with the target of collecting the Italian arthroplasty data in order to perform a specific and complex analysis, for example, survival analysis on the device. But it faces several challenges because the Italian healthcare is region-based, and thus the data are sent per region and divided into two parts, as we will see later. And the data format and quality can vary significantly among regions and along the years from 2006 up to today. And furthermore, the formal model of RIAP was only a documentation plus an XML schema shared with the participants, and data were managed with an access database. So in the RIAP data are sent, as we said, by each Italian region by means of some CSV files and are divided into the hospital dismission discharge containing the relevant information about the patient, the hospitalization, and the general practices performed in the period, and the minimum dataset containing the real data about the arthroplasties. And despite each participant is required to be consistent with the model, the complexities of the region-based healthcare bring to a situation in which there are substantial differences between the data sent by the participants. Once the data were collected before our contribution, they were unified into a single access database, and some fixing queries were run in order to correct some identified inconsistencies, and the quality of the data was assessed by means of well-known criteria. And finally, a certain number of query was issued in order to obtain useful aggregation for an annual report. It is important to highlight that this access database contained a unique table with all the attributes of interest. Therefore, from this analysis, it emerged the need for a conceptualization of the domain by means of an ontology, a relational database flanking this ontology, the insertion in this database of all the data from 2006 up to today, the orchestration of an automatic way to ease this data integration phase, the identification of a meaningful set of metadata in order to properly implement provenance and explanation of the data, and finally the selection of the best artificial intelligence algorithms in order to implement survival analysis and predictions. Focusing on the ontology, the starting point was, as I said, the documentation and the XML schema given to the regional participant, and the used tool was Eddy software, which allows a graphical representation of the ontology paired with an all-2 representation ready to be exported. And I will talk about three major aspects concerning the modeling of this ontology. And they are the modularity, because the ontology is composed by modules, the specialization management, because some property of concepts denotes also a specialization of the concept itself, and the integrity constraints both on the domain of some property and on the interrelationship between concepts. I will discuss in detail these 3 points in the next few slides. And the ontology is constituted by 4 modules, which are the patient, containing all the knowledge about the anagrammatic data of the patients; hospitalization, regarding information about the period in which a patient stays in the hospital, the diagnosis, and so on; surgery, containing the relevant information about both the arthroplasty surgery and the generic surgery activity performed during an hospitalization; and finally device, containing the relevant knowledge about each implanted device used within a surgery activity. The fundamental aspect is that the ontology as a whole conceptualizes the knowledge about the Italian arthroplasties, while considering only modules 3 and 4, it models general knowledge about arthroplasties. And talking about the specialization management, I will make an example. Hospitalization as an attribute regime, which should be daily or normal. To model this statement, the first thing is a relationship has regime, of course, having as a domain the concept hospitalization, and as a range one of the 2 values, daily regime or normal regime. And the other thing is an ISA, denoting that if the concept hospitalization exists, then it should also be the same for daily regime or normal regime hospitalization. The important thing is that both these individuals and these concepts share the same name. The integrity constraints on the domain of some property of concepts can be represented by this example. If a hospitalization is a daily regime 1, or it is a normal regime 1 and some other condition is required, then it must have a reservation date. And this statement has been modeled through the ISA described in the previous slide regarding the difference between daily regime and normal regime hospitalization and the desired condition on these sub-concepts. In fact, reservation dates exist only if this or condition is true, and this or condition is true, or if we have a daily regime, or if we had this and true. And the last, the trickiest one is the integrity constraints on the interrelationship between concepts. We have this example: an arthroplasty surgery as a cause. A hip surgery is an arthroplasty surgery, and it has a more particular cause than a general arthroplasty surgery. And this can be modeled through an ISA between the arthroplasty surgery and the hip surgery, an ISA between the arthroplasty surgery cause and the cause of hip arthroplasty surgery, and finally an ISA between the 2 relationships. In this way, conditions over these 2 concepts and this sub-relationship are not affecting the general relationship and concepts. Once the modeling of the ontology was completed, each concept became a table in the database, exception for the ISA relationships deriving from the concept specializations. And most of the roles have given rise to an attribute of a table with a foreign key to another one. As we can see, the relationship has patient become an attribute on the table hospitalization, which is which has a foreign key on the key of the table patient, which is a pseudonym. And the major design choices within the database design were the lack of integrity constraints and the fact that almost all the fields are varchar. This is to accomplish the possible heterogeneity of the data sources because they came from the system described before, the region-based system, with possible inconsistencies and poor quality data. So now there is another interesting phase, which is data integration. The starting point was the data sources, which are heterogeneous CSV files with the two parts described in the previous slides. And the used tool was Talend Open Studio software for data integration. Again, one of the two reasons is that a graphical interface enables to design the data integration tasks graphically. And the second reason is the easy connection with the database servers, for example, Microsoft SQL. And this data integration phase was performed with the 2019 RIAP data following these three steps, mapping the data from the data sources to the database server using Talend. Then manual correction were performed on the rows containing detectable inconsistency with respect to the model domain, the ontology. And finally, the addition of quality check metadata for all the tuples of all the relevant tables, for example, patient, hospitalization, and arthroplasties. After some minor corrections on the structure of the database, also the insertion of all the data from 2006 to 2018 has been performed. And so we have a system in which we can find an ontology to model the domain, an ontology-based relational DBMS as a central data repository, clear mappings between the data sources and this database, and quality metadata in dedicated tables. These has general improvements of this medical registry, which is supported by semantic technologies. And these are the existence of a common structure and ontology-based data repository, the fact that the ontology is general, the quality assessment that is no longer part of the data, but is in separated tables as metadata, and the possibility of complex analysis for RIAP thanks to this central database, and the possibility of international benchmarking between the Italian arthroplasty population and other countries' ones. Another important thing is that this analysis highlighted some aspects which are not completely implemented by the healthcare systems on the one hand, and they are also open problems for the ontology-based data access paradigm on the other hand. And they are the quality assessment and assurance, the provenance, the explanation, and the open data publication. And so the future work will be focused on a further design of more complex quality checks and corrections overall RIAP data in order to reach a stable version of the database, the automatization of the data integration phase, an in-depth study of the state-of-the-art of provenance and explanation and on how to improve them and implement them in the RIAP case study, the usage of AI algorithms to implement complex tasks of data manipulation, for example, the survival analysis on the devices, and finally, a study on what portion of the data could be published as open data, preserving the patient's privacy. Therefore, the objective is a system in which from the data sources to the database and the mappings are automated, and so they are the quality feedbacks. And the ontology is possible to query the ontology, and hopefully also to give a portion of the data as input for a machine learning algorithm to obtain predictions. Thank you for the attention. If you have any questions, please do not hesitate.